Okay, Unit 6, dealing with triangles, specifically right triangles, but that can apply to any other types of triangles as well, because actually we can take other triangles and split them into right triangles, which we'll talk about later. So why all this study on triangles? Well, triangles are actually very important in many fields. A triangle, like in building and construction and architecture, the triangle is considered the most or the strongest figure there is in terms of supporting things. Okay, if you used rectangles to support things, they'd collapse. Okay, triangles are much stronger. So we want to learn things that we can do with triangles. Now, this only has applications in certain fields, perhaps nothing that you may be pursuing, but it does help to have a good knowledge of how we can use them. Because like I said, construction, architecture, and other fields, other science fields as well, they're used. So just to review, all I want to do today is talk about two things, because we've got a short period. Okay? When you add up the three angles in a triangle, what does it always equal? 180 degrees, that's it. Okay, that's one property of triangles. So this one, how would I find the missing angle, which this, by the way, which I'm sure many of you have seen, but those of you have not, this is a Greek symbol that we often use for a missing angle called theta. It's like it represents an unknown. So how would I find the measure of angle theta in this example? Yep. It is 35, but how'd you get it?
Yeah, the 65 that we already have, and we would take that sum and subtract it from 180.
Yep. So we can take the two angles that we know, 90 and 65, add them together first, and then subtract that from 180, and we'll get 35 degrees. Or you just simply go 180 minus 90 minus 35, and you're left with your missing angle. Okay. So that's one property that we'll be using a little bit later on when we get into trigonometry. Okay. Another property of right triangles that you guys have all learned, and I just want to quickly review. Sure, yeah. You're welcome. Okay. So we should be familiar with the Pythagorean theorem, where in any right triangle, well, a right triangle, just like any triangle, is made up of three sides. In a right triangle, we often call the sides that make up the right angle the legs, and then the longest side the hypotenuse, which you, again, should be familiar with. And the Pythagorean theorem tells us that the hypotenuse, this length squared, is equal to the length of each leg squared added together, or this. Or you may have seen it as a squared plus b squared equals c squared. It means the same thing. Yep. Oh, did I make a mistake? No, you're right, it's 25. Sorry. Yep, good call, or good catch. It should be 25 degrees. So if we're given two sides, we can use this formula to find the third side. You just got to be careful where you put your given sides. Okay? You don't want to, you got to make sure you understand what side you're actually trying to find. Are you trying to find the hypotenuse, or are you trying to find one of the legs? So let's just look at a couple of examples where we use it. So here, you can always start with your formula. Remember, Hypotenuse is C squared, or C. Legs are A and B. Am I trying to find one of the legs, or am I trying to find the hypotenuse in this question? So the hypotenuse is unknown, and it's called C in the diagram. So C squared is going to be one of the legs squared, doesn't matter which one I picked for A, 5 squared, plus the other leg squared. So I have to square 5, square 12, and add them together. I get 169. Well, if C squared is 169, I take the square root of each to find C, and I get 13 centimeters. Okay. So there's an example where the hypotenuse was missing. Next example, we're given another right triangle. What's missing this time, the hypotenuse or one of the legs? One of the legs. So again, we want to use our formula. C squared equals A squared plus B squared. I know the hypotenuse C, it's 9. So I got to replace that with 9. One of the legs I don't know, but it's called X, so I need to replace it with X. And then the other one is 4, so I replace B with 4. This one I have to do a little bit of work to figure out the unknown side. So 9 squared is 81, equals X squared plus 16. Subtract 16 from both sides, and X squared will equal 65. Therefore, we take the square root to get the answer. Now, in pre-calculus math, you're used to showing your answer in a different way. In this course, because it's more practical, we would just use our calculator and round it. So it says nearest tenth, so 1 decimal place. So X would be approximately 8.1 millimeters. In pre-calc, we would leave it as root 65 because we might do additional calculations with it. And then, of course, one thing that we do more of in essentials is instead of just doing like these triangles don't really represent anything, let's look at situations where you would actually use Pythagoras. So firefighters have a 17-foot extension ladder. In order to reach 15 feet up a building, how far away from the building should the bottom of the ladder be placed? Well, best thing to do in a situation like this, draw a diagram of it. So here we have our building. Here we have our ground. We assume that they're going to meet at a 90-degree angle, that there's no slope to the ground. And then we're leaning the ladder up. So you can see that the one side of the building, the ground, and the ladder make up a right triangle. We know this is 17 feet. We know that it reaches 15 feet up the building. This, and I'll call it D for distance, is what we're trying to figure out. So what am I trying to find here? A leg or a hypotenuse? A leg. So got to remember that when you plug in your numbers into the formula. The hypotenuse I know is 17. One of the legs I don't know, I've called it D squared. The other leg I know is 15, so I've got 15 squared. So it looks very similar to the previous example. 17 squared is 289. equals d squared plus 15 squared is 225. If I subtract both sides by 225, I will get 64 is equal to d squared, which is a nice clean number to take the square root of, which gives me 8 feet. Don't forget your units. So that's just a quick review of a couple of things that we do with right triangles. The sum of the angles in any triangle, whether it be a right triangle or any other type of triangle, is always 180. But for right triangles, we can use this formula to find missing sides. We may be interested in find missing angles in right triangles where we can't use the sum as 180 degrees. We may be interested in finding a missing side where there's not enough information to use Pythagoras. That's where trigonometry comes in, and that's what we'll do tomorrow, a review of that. Okay? So you've got exercise 6.1 there that you should be working through.